today. So today our tasks are to use or not to use algebra and then the dream job salary task. The whole point is to learn about mathematical representations to solve problems. And so we're going to use that to get into linear, exponential, and quadratic functions. Now, quick note or comment slash something I want us to think about before we jump into this task is what are the mathematical representations that we have looked at? Give me one, Maddie. Or don't give me one. Raise your hand if you want to share one of them.
One of what?
Of the mathematical representations we've discussed. Okay, so does anyone remember the name that equations fall under?
Vocabulary?
The what class are we taking? Algebra, right? So equations, expressions, inequalities with those variables, things like that, those are algebra, right? Okay, so we got algebra. What else do we have? Oh, wait, raise your hand. Go on. Pictorial. Jamie. Oh, I'm so sorry. You don't know any others? Okay. Addison. Tables, right? So we've got algebra, pictures, tables. What else? No, you already went.
Oh, graphs.
Graphs, right? Graphs are a pretty big one. And did you forget verbal, right? So remember, we can represent mathematical ideas through those 5 different representations. And so when I say mathematical ideas, one of the big things we're talking about there is the idea of inputs and outputs. Does anyone remember what we call a relationship between inputs and outputs, or where an input is mapped to an output? Everybody remember that name? It is a vocabulary word. Mr. Hobby, can I get you, actually, let's do this. I'm going to pass out the proficiency scales. If Mr. Hobby, you can grab the mathematical representations, check your understanding, and Frere model. Okay? So we are specifically looking at the side that says identifying functions right now. It should say, yeah, the other side it has blank break. Yep. So, well, hold on. This is a stack of just that. Aw, you poor baby. You can't pick a sheet of paper up off the ground?
It's over there.
You could ask her, politely, to pick it up for you.
You just want to have it.
It is, but we're about to move. That's, oh, did I already give you all the identifying functions one?
Yeah, very good.
It's okay, the next one that you need is on the back side, so it's fine. I was wondering why, I thought I had printed those out and I couldn't find them. It's because I already gave them out. Alright, so let's do this. Let's consolidate groups a little bit. So I got one. Okay, so Kenny went ahead and moved. We got one blank there, one blank there. So that's it. Caden, why don't you join the Kings? And that way we can consolidate those groups a little bit, okay? Alright. Okay. Alright, so here's what I want us to do at this point. Oh, I'm sorry, Kenny. I forgot you moved. Did I not get y'all at all? Okay. I knew I put some out. Just kidding. Alright, so does anyone see a vocabulary term that would be a relationship? Another way we can say that is the proper math term is actually a mapping of inputs to outputs. So if you look at the identifying functions, so functions tie into this, but it's not a function. A relationship or a mapping of inputs to outputs is just... No. Look at the vocabulary on the identifying functions proficiency scale. What's the term for a relationship or a mapping of inputs to outputs?
Foundation.
A relationship between inputs and outputs, a mapping of inputs to outputs. What do you think it is? A relation? Wait, so this thing is just simply called a relation. Don't make it more complicated than that, guys. A relation is a relationship or a mapping. Mapping is the proper term there, of inputs to outputs. And we're going to do more with that and build into functions. But we got to know the term relation first, because when we talk about the mathematical representations, Brady, give me one of those mathematical representations again. Algebra. John, give me another one. Pictorial. Okay, Cameron, give me another one. Cameron, do you even know I called on you? You don't know one of the others? Okay, so I need you to pay attention because we just went over all 5 of these. All right. I need someone who hasn't given me one yet. Amber. Graphs, right? So what have we said so far? You went with algebra, pictorial, graphs. Macardia's got tables. Remember, equations are under algebra. Say again. Verbal, right? Those are my 5 mathematical representations. So how can I represent or show a relation? Through those 5 things. So Cameron, give me one of those 5 things. What's a way that I can show a relation?
Algebra.
With algebra, there we go. Jaquel. A table, there we go. Kennedy. One of those ways we can show a relation. A graph, there we go. Kamai, have you given us one yet? Give me one more. So we've done algebra. What did you say, Jaquel? Table? Table, graph. Girl, this is the 3rd time we've gone through this. Okay, so I need us to pay attention to this. All right, Alexis, can you help us out? Verbal. We got one more. Anybody? Pictorial, pictures. Tables, graphs, equations, algebra, words, verbal, and pictures, pictorial. We've got to know the 5 different ways. So it's going to impact our ability to enter into the task that we have today, which I'd be able to get to if I found the remote sitting in my pocket. Thank you. All right, so we need to create and use mathematical representations to find the answer to posed problems and solve algebraic representations of posed problems. So please hear me clearly. These are the 2 literal objectives, but the real objective behind this is we are used to being lectured to about an equation and then like doing a bunch of practice problems with that equation, and then that's it, okay? We are going to get practice starting Tuesday or Wednesday, but I want us to understand these equations before we start just trying to do stuff with them. And so we need to understand how to create mathematical representations to make sense out of the functions and the equations we'll be dealing with. And in this algebra, those equations, solving problems, that's going to help us review solving and simplifying from Algebra 1 in middle school and geometry. So, we talked about to use or not to use algebra. Each of these problems, you have to solve them 2 ways. What were the 2 ways? Using... It's still up here right now. Using algebra.
Another without.
And another without algebra. It has to just be algebra and one without algebra. And so I think we already finished bottle and cork yesterday, right? Like I kind of wrapped it up at the end. So the bottle and the cork, right? Remember the bottle plus the cork had to add up to 315 grams. And we talked about the fact that the bottle had to be the cork plus 300. Does that sound right? Remember those details? Sound familiar? Now, I want to emphasize that I don't think I talked about this yesterday. I need y'all to pay attention because this is going to help you moving into the next task. So I need all eyes up here, not zoning out, okay? Not letting headphones distract us. So not listening to other stuff. We're focused right here, right now. By the way, let's just make this a general rule to help each other out. No earbuds, no headphones in the middle of class, period. You can't hear effectively and engage effectively. So let's go ahead and take them all the way off. Let's put them away. All right. From here, we solved this problem. We did. We guessed and checked. I think creating a table is basically the only way we solved this. Is that right? Did anybody solve it another way? No? Okay, so let's do this. I believe I gave you another Frere model that looks like this, but it said just to use or not to use algebra mathematical representations. Can you get that out for me? And if I didn't get it, give it to you, let me know. Because I want y'all to have notes from this right here to help moving in. Huh? It said to use or not to use algebra.
I see it, I see it.
You didn't get one or you lost it? It looked just like this. Well, it's weird. I only have like 3 left, so that means like we got them lost. Have we actually looked at our notebook, Macario? Did you? I don't see that notebook out. Oh, is this it? Y'all. You can turn to this. That's totally okay. No, to use or not to use algebra. This one. You gotta get this one. Okay. It's easy if you just put it into the notebook in order. Tyler, you got this? Great. Come get it. Passed this out 2 days ago, I think. Yep. I'm pretty sure you can hear. Ooh, by the way, really quickly, before I forget this, I'm starting to notice a pattern that even with random cards, a couple of us just magically seem to end up in the same group every time.
I haven't noticed it.
Yeah. And so if I have to, from now on, I'm going to tell you to come in and sit in any group you want and waste class time giving you a card and watching you move to the right group since we're high schoolers in class and don't know how to not switch cards. Okay, don't switch cards. The whole point is to learn how to talk with people you don't know and to mix ideas. Please hear me very clearly. Some of us, I get it, are uncomfortable talking with people. But for the rest of your life, guess what you're going to have to do? Talk with people and communicate. Second, if the same people consistently sit together and sit in the same groups, then that means ideas are not being shared and those ideas are sticking with one person. The whole point is that everybody can learn from everybody. And so we need to share those ideas and move around the room. Am I clear? Okay. So, when I pass out cards, if I continue to see us sit in the same seats week after week and with the same people day after day, we're going to have to change things up. It ain't. That's not how random works. It's not how random works. All right. And I have methods to get around it if it is such a coincidence. I can do it digitally and put your names up on the board so that we see exactly where it's supposed to go where. Dewan knows all about that, doesn't he? No.
Yeah, it's a random.
It's a random team generator online. All right. Pull out right there. Okay. So here's what I want to talk about. So first things first, we talked about a table, okay? And I think some of us did this table. And I'm going to come back to this in a second. We did bottle plus cork, right? That was an expression.
Yeah.
By the way, did you notice that this bottle plus cork literally ended up right here in this equation? So if we had written that out and used that, then that could have helped us write the equation. I saw some of us writing stuff like 300 plus 15. Notice, what does that 300 represent? The bottle. And so some of us even put a B for bottle above it. 15 represented the cork. And so when I see things like this, I don't know originally what the values of the bottle and the cork are. But guys, in math, what can we use to represent something we don't know? But building block of that equation is a what? You just said it. Variables, right? Variables simply they show things. That's not the language I want to use. What? They represent. There we go. They represent unknowns. Can you grab that, Mr. Armstrong? Okay, I got that. Yes, sir. Yes, I do. Will do. No problem. Bye. Mr. Armstrong. I see you. Good to see you. All right. So they represent unknowns and are able to. Any guesses? Able to vary. Oh. It's like the word variable means something, right? When you break down the word itself and we just say, hey, it's a variable, it's able to vary. It's something that's unknown. And so to figure out what it actually is, we need to use a variable sometimes. So B plus C is equal to 315. The other thing I want to point out is the language matters. I can't remember if I mentioned this yesterday, but the way I word it is a little bit different than here. I say the bottle weighs 300 grams more than the cork. Did I talk about what this verb right here usually translates to in math?
Weights.
Yeah, but like in math, what does a verb usually translate to?
Weights.
Equals. Notice how the bottle, the unknown B, right, weighs equals 300 more than. By the way, 300 more than, what would that operation be? 300 more than. Adding how much? 300 to the cork.
Yep.
If we read the statement there, that verbal, you see how I can translate it into an algebraic? Instead of just struggling with, if I understand how to read and understand that, hey, that verb's going to become my equal sign, more than just means to add on to. Now I have an equation. Okay? Now from here, what I want to point out is this bottle, actually, I'm going to pause for a second. I want you to write down any notes that you need to under the bottle and cork problem based on what we've already discussed. So what do you need to write down to help you remember mathematical representations and how we started this? Notice the context of the problem is still up on the board. If you want to write that down. What? No, she didn't have it. Well, I'm saying write down what you need to help you remember multiple representations, to help you remember how are we getting an equation out of these statements here.
Well, I mean, you could have went some. You on wall fit?
I'm what? I'll sit there and be terrible with this right here. That hurt.
You just said it don't hurt.
Everybody okay?
I said if I did a wall sit, like an actual wall sit, this would hurt. This does not hurt. I mean, we do. I'm gonna say we do squats most days of the week at the gym, so I gotta have decent mobility.
You know, you should be a boxer.
No, I like my body the way it is and not destroyed like that.
You'd be a good boxer.
I don't know about all that.
Kenny the boxer. That sounds like a Kenny does.
A boxer name?
He can't be the boxer.
Sounds like a golf.
You look like an album cover on the video.
Do what?
You look like an album cover on the video.
Oh, that's fun. Alright. Just another minute or so, then we're going to continue. Alright. Mr. Hoppy, can you grab the cards for me?
Cards.
Okay. So, here's what I want to address really quickly. Alright? Really quickly, here's what I want to point out and I want to address. Out of the algebra side to help support you in moving forward, I will point this out that if my bottle was 300, what could I do with this 300 and this B?
Can I have your card? No, you're totally fine.
If I were to say the bottle is 300, say again. Okay, does anyone know the more mathematical term than just replace the B with 300?
It's a variable?
It's an S word. And not subtract. I literally was about to say it.
Say
Say it again, I heard it. Substitute. Guys, if two things are equal, then I can substitute it in, right? Usually, there's two running backs on a football team, right? So can I substitute one running back and send one running back in the place of another? That's the idea of a substitute, right? Sending something in the place of another. So I could substitute that 300 in. Now, we've already done this though, right? Notice if I put 300 here, just looking at it, what would C have to be in this case? 15, right? But if I had substitute 300 here, what would C have to be? Here?
Wait, what happened?
If I were to substitute 300 into here, what would C have to be?
You had to be,
Guys, what plus 300 equals 300? 0. So notice, can the bottle be 300 grams?
I think it's your brother.
No, wait. Okay?
Yeah, you said that it's going to equal that substitute, right?
You can substitute. Okay. Now, the reason why I bring this up is, what is the bottle equal to that I could substitute in right here?
335.
What?
Just look up here. What is the bottle equal to that I could substitute in for it? You guys don't make it complicated.
You said again, you said
What is the bottle equal to so that I can substitute it in? Is the bottle equal to 300?
Yes.
Look at your, no, it's not. Look at your equations.
300 more.
It's 300 more than the cork. Okay, now we're getting somewhere. The bottle is equal to 300 more than the cork, right? So what can I substitute in for the bottle? Okay, let me ask this. Chelsea, what is the bottle equal to?
What, that's right.
The cord and 300 more.
Okay, so the bottle is equal to the cork, but 300 more. C plus 300, right?
Yeah.
So John, what could I substitute in for the bottle?
300.
John, no idea? Okay, I'm going to come back to you. Chelsea, remind me, what is the bottle equal to?
The cord and 300 more.
The cork and 300 more. Like literally, what does it say on the board? No. Right here, that I circled. C plus 300, right? The bottle is equal to the cork plus 300. So, John, what could I substitute in for the bottle? Is the bottle equal to just the cork? No, what is the bottle equal to? The cork, there's a word I'm missing. Plus 300, right? So, hey, what could I substitute in for the bottle? What's it equal to?
Cork plus 300.
The cork plus 300, right? So, John, what's the bottle equal to?
Hey man, you asked for the actual.
Oh, no, it is.
I'm getting my right.
Guys, right here.
Yeah, are you asking for the actual
No,
answer?
right here. What is the bottle equal to?
307.5. Hold on. Oh.
Okay, but literally, stop making it more complicated. Don't look over here. What is the bottle equal to? C plus 300.
That's it.
So, what can I substitute in for the bottle? Say it again, Addison. This is what the bottle equals, isn't it? But I'm asking what can be substituted in for the bottle?
You just have me saying question 3 times.
Are you the only one in this classroom?
Everybody said it.
No, everybody did not say it. Okay, so what's taking the place of the bottle? What's being substituted in? The quart. Plus 300. Woo. All right. Now, I want to leave it here for a second. I want you to go to your vertical surfaces, and I want you to use that equation to find what the weight of the bottle is and what the weight of the cork is. Please leave this here. You can erase anything else. Come on, work together. Let's find the value for the cork and the value for the bottle. I'm ready for that too, but anytime I got that one. Just look at this, Jaquel. That requires us to turn around. What's in your pocket? Nothing? Then why were you turned around like that?
I ain't got nothing in my pocket.
Hoodie pocket? So, C plus 300 plus C equals 315. That alone doesn't tell me the answer yet. It doesn't tell me what C is. But if I can get an equivalent equation, maybe something that looks different but tells the same story, I can find what C is. Does anyone know how I could rewrite this equation? What? 2C plus 300. Where is that 2C coming from?
The 2 C's.
Okay, I want you to hear me clearly on this. Literally, how many C's do I have?
2.
I have 2 of them. So why is it 2C? I need you to pay attention because it's going to sound very simple at first, but there's a key here that we have to understand. What is happening between the 2 and this C here? They're being multiplied. Why are we multiplying C by 2?
2 C's. Oh, and you said like on whatever's equal now.
Not the distributive property. What is 5 times 3?
15.
Why is it 15? And not just because it is.
Because you go 5 3 times. Not by 5.
What, you say 5 3 times, do you mean like this?
5 plus 3.
Not 5 plus 5 plus 5.
Oh, it's 5 plus 5 plus 5?
Yeah.
So what you're saying is, and you need to note this, multiplication is, say it to one, is repeated addition. Okay. So when you see repeated addition, what should you immediately think of? And if you see multiplication, what should you immediately think of? Repeated addition. Guys, you need to log this in your brains because this is going to be foundational to everything we do. So 2 times C, because I am adding C how many times?
2.
2. Now I have an equation that may look more similar to what you're used to. What can I do to solve this equation, Mel? What did you do right there? Oh, it was Cameron? Sorry, Mel was standing next to it. Cameron, what'd you do?
What was the question?
What did you do to start solving that equation? Okay, now let me ask you a question. Did you subtract 300 here first, or did you subtract 300 here first? On which side? On the left side? Do y'all think it matters? So, we do have to do it on both sides, but it actually does matter in the order of understanding what we're trying to do. What am I trying to solve for? C. So I got to get rid of the stuff around that C. What gets rid of 300? The plus 300. Minus 300. 300 minus 300 doesn't just cancel, it makes a 0. And then whatever I do to one side of the equation, I have to do it to the other. Now I got to point this out. Okay, I've got 2C equals 15. Does that look like what we started with? No, but because I simplified and I used a property of equality, it looks very different, but is that easier to know what C is?
You gotta divide it now.
I could divide it, right? Because there's multiplication. The inverse of that multiplication is division. What I'm going to do is, so this 2 is understood to be divided by 1. I'm going to recommend that you use something called the reciprocal. We'll talk about this when you get back from lunch.
Am I in it?
No. All right.
No.
Is that because you don't want the camera to catch you doing things you shouldn't do, Brady?
Oh, I said you.
Sure.
Then you thinking my
All right, really quickly, right here. So to finish this up, I want to emphasize and point this out. Remember, I think it was Preston, you said to divide by 2, right?
Yeah.
Okay, listen. Yes,
That
ma'am.
was 7 and a
I
half.
love how much time that's.
Guess what? If you add both of those.
I don't know what you call it. Huh? Your what?
My favorite is my favorite.
All right. So, I just need us here because I need y'all to see this because it's going to help you moving forward. All right. So, hear me clearly. Every year, students look at me and go, Mr. Kinney, I feel like that's more complicated than it has to be. And my response every time is, there are things in math that I know that are coming up so that if you can trust me and pay attention to this, it is going to help you long term. Go on. Karin. So, here's the thing. Can I, when solving this equation, simply divide by 2?
I don't even know.
I mean, what's 2 divided by 2?
1.
1. Okay? And so 1c is equal to 15 divided by 2. Totally valid. It's easy enough. That's true. I can divide it even and get the 7.5, which 7.5 grams is what some of us found. However, this 2 is understood to be divided by 1.
Right.
So I'm multiplying by 1/2. Because when we get into exponential functions, understanding fractions is going to help you a ton. So I'm asking you for your sake, please start trying to focus on using this reciprocal. You will always see me use what's called the reciprocal. Okay? It can also help, okay, whatever I do to one side, I have to do to the other. I'm still making a 1, because what's half of 2? 1. What does this fraction bar right here mean? Divide by, right? So this 1/2 is still dividing by 2. It's just an alternate way to write it, but it will help you long term. Okay? So please trust me on that. A clear example is this. Okay? If I was doing this and I were to divide, in this case, what would I divide by?
3 and 2.
I wouldn't divide by 2/3. I would divide by,
2/3. I mean,
right? You gotta divide by itself, right?
right.
Anybody know what 15 divided by 3/2 is?
5. Oh,
You did what?
Anybody know what 15 divided by 3/2 is?
5 and a half.
What? Are you doing?
Right here.
No way.
Watch this though. Hey, what's the reciprocal of 3/2?
3.
2/3. So if I multiply by the reciprocal 2/3, what is 2 divided by 2? 1. What is 3 divided by 3?
1.
And now whatever I do to one side of the equation, I got to do to the other. Now,
Yeah.
if I understand that fraction bar's division, what's 15 divided by 3?
5.
And what's 5 times 2?
10. Just the answer.
That would be the answer. If you learn to use the reciprocal can make it easier long term. So do you have to? No. Is it better for you long term to practice using the reciprocal?
Yes.
Yes. So go ahead and start practice using that reciprocal. All right. What don't make sense?
How's it 10? But you said that it's 300 more, so that'd be 310 plus 10.
No. I made up an example here, dude.
Oh, okay.
Yeah, I was just trying to illustrate why the reciprocal would be better. Preston, remember we just did it up here. It was 7.5.
Okay.
Yeah, I got you now. But please notice that was 7.5. Okay?
You didn't sound right.
I will in a second. Just hold on. Okay? Notice I can use that to then find out what the bottle is because 7.5 plus C. By the way, right here. Notice how we just said C is equal to 7.5. So what can I do with the 7.5 to figure out what the bottle is?
You added it.
Yeah, but there's something I would need to do mathematically before that. Starts with an S.
Simplify. I know you don't know.
Substitute.
Substitute. What would I substitute 7.5 in for?
C.
The C, because they are equal, right? Things that are equal I can substitute in. So notice we're coming back to that idea, all right? By the way, does anyone know what this is called when I have more than one equation?
Equations.
Yep, good job. I have more than one equation. I have two equations specifically with how many variables?
Yes, it's two.
Two variables. This is known as a system of equations. Okay? It is more than one equation, and it's a system because they are working together. Don't systems work together with each other? That's why it's called that, right? So if we learn to break down the language, right, come on? Breaking down that language, understanding what system means, a system works together. So it's a system of equations, okay? Now, what method then did we use to solve this system of equations?
Get.
Oh, mathematics.
Remember how we substituted in earlier? So it's called what method? Substitution method. Guys, like these words and these methods, I know it's a lot of stuff coming at us right now, but this is all from Algebra 1. These methods, these names have meaning, and that's what I want us to understand. If we understand what these words mean, then it's going to be easier to remember the techniques. So, substitution method, literally because I'm substituting in. Okay? So there's substitution method there. One last thing before we go into the next problem, actually take notes, and then the next problem is this. This is an alternate way to see it. If the bottle is equal to the cork plus 300, what's the difference in the bottle and cork equal to? What's the difference in the bottle and the cork equal to?
You said what?
If the bottle is equal to the cork plus 300, what's the difference in the bottle and the cork?
It ain't no different.
It's how different?
300.
It's 300 different.
Oh, you said the cork in the bottle?
Yeah, dog. The difference
I thought you
in the
said
bottle and the
I
cork.
thought you thought the whole thing together.
Okay. Now, you should have done this in your Algebra 1 as well. If I added these two equations together, what's b plus b?
Z.
Notice that's repeated addition, so it becomes
Elite.
multiplication. Right? When we say 2b, we mean 2 times b. b plus b is 2b. What is c minus c?
Zero.
That's 0. Anyone remember what method we call this that I'm using right now?
The ABC method. No way.
Oh, what just happened to that variable? It was eliminated, right? So when I have that what's called standard form, I can use the elimination method. And I'm adding these two equations. Alright, so what am I going to do to solve for b at this point?
Multiply.
You're gonna divide.
Inverse.
Can divide, but how did I recommend doing this? Remember, the same as 2 divided by 1.
It equals 2. I mean 1. My bad.
Not divide by 1/2. You're close. Multiply by 1/2. Remember, it's the reciprocal, right? When that fraction flips. Remember, you said divide by 2, right?
Yep.
What does this fraction bar mean?
1/2.
Divided by.
Divided by 2. So multiplying by 1/2 divides by 2. So 2 divided by 2, 1. And half of 6/15. Does that number look familiar for the bottle?
Yeah.
Oh my goodness, it's like, there's multiple ways to do this. Okay,
I did 2 ways.
say again. Hold on, what did you say, Preston? Okay, so please notice, some of us, we didn't put it up here now, but some of us create tables to find the answer to the bottles and the cork. Wait,
Oh,
or mass, yes.
Yeah.
Did, we struggled on the equation, but I'm going to give you a chance to write down notes about this solving method so that you can use this in the future. Have we looked at this graphically yet, though?
No, not from the graph.
Okay, so I need everybody to go pick up a calculator. Let's rephrase that. One person per group go grab calculators for the entire group. One person per group go grab calculators for the entire group.
Okay. So that little black. That's one way to solve the equation.
This is someone else's writing. Remember, I always use purple.
But
But they were, huh?
7.5 be the answer.
Look, I remember when they were there, I write blue. Do you see that in blue over there?
Right. 7.5 be the answer, right?
What do you think?
Yes.
Oh, somebody's on camera.
Yes, Tyler.
You got it.
Yes. All right. So, I need everybody to create a page. By the way, what representation did I say we're about to use?
Graph.
A graph, right? We're going to use the graphing. So you do not need to log in. Good question. You just need to create a graph page. So, ladies and gentlemen, I need you to create a graph page. Do you know how to create graph pages?
Yes.
Let me ask this. Do you know how to create a new page? That's a graph.
Yes.
Okay.
I agree with that.
Okay, hold on. But let's say, guys, if I can get your attention really quickly, I need you to learn this technology skill. Let's say I made a mistake and I added a calculator. I don't want to go back to home and create a whole new document or anything like that. If you look above the word doc right here, where is my cursor? If you look above that word doc, what does it say in gray on your calculator? It says plus page, right? So do you know what I have to hit to be able to do plus page? I need to do something first. Control, right? It's in gray because the control button's in gray, so that when you hit doc, it's going to give you a chance to add a new page. Card. Look at the word doc. What's it say in gray? No, you got to have a calculator page first. Guys, you have to have a document already there. My point is just how to create a new page. So you don't have to create a new document every time. Say again?
Personal preference.
Personal preference. No, hit escape, dude. You've got to hit escape. Top left. You've got to hit control first.
Gotcha. So now what?
Create a graph page. Does it give you that option?
No.
Okay, I will come and look at it. Hold on, sorry. All right. Eyes and ears right here. So pause for a second. Let's make sure we see this. All right. So what it's asking us to do right now is to graph a what? What is? Anyone remember what f1 of x stands for? Function. That's a function. Yeah. When we say f1 or f of x, that's known as function notation. Where what's my input? The x. What's my output? Okay. So f of x or y. So x is input, f of x is y, or the output. But I want to point this out. If we have b plus c equals 315, does that say y equals? Even if I were to convert this to x and y, does that say y equals? No, so I can't use function. So when you have this graph page and it looks like that, hit escape for me. We'll create a new graph page.
So you gonna show how to make the new graph page? No.
Say it again.
You gonna show?
Did it say f1 of x at the top? If it said f1 of x at the top, yes, hit escape. Now you do need a new graph page, so make sure that you have a new graph page created, otherwise this isn't going to make a lot of sense. Now, okay, Caden, what's the button I'm going to hit to do cool crap? Caden. Huh? Yeah. What other button? I don't think so. Not to do cool crap. Jamie? If I want to do cool crap on this calculator, I got to hit what button? Menu. Hit the menu button. Okay? Notice it gives me lots of options. And I want to enter I want to create a new graph. So where am I going to go to create a new graph? Oh, literally it says graph entry, doesn't it? Oh, man. Hit graph entry for me. Now remember how we just said we can't do function?
We can do relation.
Oh, I bet we could do relation. You're right. Go to relation. Because that's just a mapping of inputs to outputs. Now, hey, just
Show me how to reference.
okay. So what I need you to do, because we have two different equations, I need you to graph both of those equations as a relation. So you're going to type one equation in. Notice we have to switch it to x and y for the calculator. But type the first equation in, hit enter, and go back through the process to add another graph. Right, Preston?
I kind of slowed down for a second.
I can tell. Graph both those equations.
Which equations?
Type it in. Yeah. By the way, do you know where the equal sign is?
Yes. Enter.
Nope, not enter. Right below control, there's an equal sign. Hey, Maddie, let's make better decisions. I don't know what he did first. I saw you. Fix it. Dewan?
I haven't.
Fix yourself. Maddie. Pause. Instead of retaliating, you tell me and I take care of it. That's not your job. It's my job. You tell me. Okay? So, Dewan, step up. X plus y equals 315, right? Literally at the bottom of the calculator, there's letters there. Type in x plus y. Then hit the equal sign. 315. Hit enter. Come on. All you have to do is create a new calculator. I said you don't have to learn it. The equation is still on the board. Do functions. We have to do graph entry. You're entering the graph. We have to do relation. Now type the two equations. Type the first equation, the second one. Then hit enter. X plus y is equal to 315. X minus y is equal to 300. Okay, now type your second equation in. So, guys, look, x plus y equals 315, and you hit enter. And then what's the button lets me do cool crap? So I go back to menu, go to graph entry / edit, then to relation, then x minus y is equal to 300, and hit enter. I know you can't see anything. Just trust me for a second. Yes, sir.
Okay, I need that.
What are you trying to add?
Where?
Trust the process, guys.
What are you trying to create? Not analyze it. We have to the equations. So right there on the top, x plus y equals 315 and x minus y. Okay, I know you can't see anything. You got both equations in though? Yeah? We got equations in? By the way, guys, I know some of y'all freaking out. You're like, but Mr. Kinney, I can't see anything. Neither can I. The two equations. X plus y equals 315, x minus y equals 300. Hey guys, what are x and y adding up to?
300.
It's not
Huh? 315. There are two equations you have entered in. Guys, what are x and y adding up to
Right now,
in the problem?
315.
They're adding up to 315. Hey guys, what's my x going from? Negative 10 to 10. What's my y going from? Negative 6 to 6. But I have to add up to how much? 315. So I got to change my window. What button lets me do cool crap? Okay, hit menu. Once you have your equations in, hit menu. Okay? Where am I going to go if I need to change my window?
Windows.
Oh man, it's right there. Window / zoom. Just read the options. Go to window / zoom. And you can use zoom. However, it is a better idea to use Windows settings. Because that's going to give you more control. So go to Windows settings. Now we already said
Where do you see that at?
Windows settings. No, it's at the top of Zoom.
You see it?
Did you go to Window / Zoom, Preston?
That person?
Is it the
Bakari, let me take care of it. Alright. So just in case we missed it, menu, cool crap, Windows / Zoom, Windows settings. Now, guys, we already talked about it though. What is the maximum that the bottle of the cork could weigh? Like, what do they have to add up to?
315.
Well, 300 more, they have to add up to 315, right? So probably not much more than 315. So what should I make my maximum X value?
320.
320. I might go to 350 just to be safe. A little bit more, right? So I'm not worrying about the minimum, I'm just worrying about making sure I hit the maximum. What about the maximum y? Say again. I would, again, I know the two of them added together have to add up to what? 315. So I will say my y is my cork in this case. So do I need to go as big as 350? No. Maybe 50, maybe 10, but something bigger. And I'm gonna hit OK. Ah, it don't look pretty, but can I see it now?
I see it now.
Guys, the y maximum I made, the x max I made 350, because that's the bottle, that's big enough. The y max I made 50, because that's big enough to see the bottle, or see the cork. So you go to the y minimum, y max, or x maximum, y maximum. Mikhail, how's that going for you? Dude, I'm telling you how to step through button by button, and you're not even picking up the calculator. So, ladies and gentlemen, anyone see anything that could be helpful here to help me answer this problem? I did 50. Just kind of guessing, although we didn't have to.
Okay, there you go.
Okay? So, it may not look exactly like this, but does anyone see a point that might be helpful in trying to solve this problem?
No.
Nothing. How about you look at something with the lines? What about those lines?
There's a part where like they
That's where they connect. Anyone remember that term? They intersect each other. Man, it'd be nice if I could find out what that point of intersection is. Hey Chris, I want to do cool crap. What am I going to do? Menu. Okay, so let's look at menu. Anyone see anything that's going to help me examine those graphs a little bit closer? We're going to what? Oh, we can analyze that graph. Huh. Okay, okay. What do I want to analyze? The intersection. Guys, follow the words. They tell you where to go. This is why our language is important. We want a point of intersection. Now, remember with, no, we didn't do this in this class, so let me show you this. When it says lower bound, that just means to the left. So my point of intersection is here. So I just got to make sure I'm to the left of it. See how that line's to the left? Use your touchpad to do that. So make sure you're to the left, and then hit enter. What does it ask for now?
Upper bound.
Upper bound. So I'm going to go to the right, and then I'm going to hit enter. And what point of intersection do we have?
But what you do until you get 30 stuff.
So you'll say 4.5.
Wait, so that was my bottle and that was my cork, wasn't it? They add up to 315. They have a difference of 300. So, upper bound. If lower, no. If lower bound is to the left, upper bound is to the
The right.
the right, dude. You got to go to the right of the point of intersection. Yeah. All right.
Thank you.
So pausing. I need you to make whatever notes that you need to your future forgetful self about the bottle and the cork, about solving the equations using substitution and elimination, or about creating a graph to find that point of intersection. By the way, did the different methods give us different solutions? No, they definitely did not, because these are different things that are telling the same story. Anybody know what we call something that looks different but tells us the same story? In mathematics, there's an E word.
Equal expression?
Closer with equal, not expressions, equalities. Say it again. They are equivalent. The table, the graph, the equations, they look different, don't they? But did they tell a different story?
No, not everything.
No, they told the same story, right? So they look different, but tell the same story. That's why the representations are important. If you're lost on one of them, create another. So take what notes you need to. I need y'all to note this. So guys, make what notes you need to, not talking. Notes what you need to, or ask questions from me if you need to about the calculator, but make what notes you need to about solving it algebraically. Maybe the idea of using inverses. The idea of C plus C, that multiplication is repeated addition, right? If it's in blue or it's in purple, that's something I felt important enough to write somewhere.
What color blue? I mean purple or what?
Purple is on the whiteboard, blue is on the chalkboards.
Jeez, that's a lot of.
Jamie.
I'm not right on it.
But I just.
I can't see the board side to board.
John.
So,
Shut up. You said you were going to throw the calculator at the 7. What do you think? He keeps smiling. I'm scared. He keeps smirking. Oh, wow. I don't like you.
I got it.
Hey, excuse me?
what?
You're excused.
Wow.
I was just checking time.
Oh, wow. You can't believe you, Jamie.
You don't always have to say something. It's my job.
Listen.
Hey, Jamie, did I ever take care of that?
Well, tell him to be quiet then.
I just did?
It's no longer.
Hey, you could ask him, you said told him instead of asking him. You can also
What time was
whisper
it?
Alright. But Kamai, you started that.
Hey, Jamie.
Hey,
Jamie, what time was it? What time was it?
Preston?
128.
I just wanted to know the time.
I didn't see that far.
Okay, guys, go on. If you're done taking notes, don't distract others. Just wait. Please again notice, right? These notes about mathematical representations, about solving. Remember, one thing with solving, simplify. Remember how we did C plus C was 2C? Then what did we use? Starts with an I.
Invert.
Close.
Inverse.
Inverses.
Yeah.
So with solving, simplify, then use inverses to solve for the variable. Hold on to a lot of these key ideas, like with solving, simplify, then use inverses to solve for the variable. Multiplication is repeated addition. Equivalent, they look different, but
They're the same. I mean, that's okay.
tell the same story. And I do say it that way because you can get the same result with things not being equivalent, but literally they look different, but all the way through they tell the same story. Okay? So from beginning to end, they tell the same story. Where? Oh, no, I'm just saying we're substituting an expression in. Like into the equation, if you want me to finish that. But then we substitute C plus 300 in for B. So I could say in for a variable, but yeah, I didn't. Hey, I'm giving y'all two Frere models today, correct? Or the two, yes. Okay. All right. We are going to start the next task about entry fees on Tuesday, but I have one more thing that I'm going to cover with y'all quickly.
Oh, yeah.
Every time it's getting.
I'm trying to learn.
Take your time.
Let me see your notes.
Yeah.
See, color
Come on, get off the phone.
Bakari, you worry about yourself. I just took care of it because she asked
I just
me.
think
No, no, dude.
Period.
No. Stop.
You're gay. You're gay. You're gay.
Trying to get folks in trouble.
No, I'm talking
You like it?
Alright. So this is the check your understanding of stuff that Mr. Hobby passed out at the very beginning of class. I need you to get this out really quickly. The one that says functions and mathematical representations. I would definitely make sure this goes near the proficiency scale that you got today. Huh? That's what? No, I made that new this year. I was like, I literally was up until 10:30 or so doing school stuff 2 nights ago and 10:30, 11 last night doing new things like that, because I didn't start doing that until this year, really. Like I started it last year, but. Alright, so let's do a quick recap. Something we should already have written here, hopefully, is the idea of a relation. What is a relation?
Match, internship.
It starts with an M. It's a mapping, right? A relation is a mapping. That's some kind of relationship between what?
Two and four.
Okay, but we call those, the values of those variables something.
Inputs.
Inputs and
Outputs.
outputs, okay? Now, I need y'all to pay attention to this. But how is that different from a function? Who remembers what a function is?
Oh, not a relation.
It's
It's not a relation.
So it is a relation.
Oh, it is a relation.
It is a relation.
It's
It's got inputs and it's got outputs. But it's got a special requirement.
well,
What are you saying, Jamie?
about.
Not equal.
1 to 1.
There is a one-to-one function. That's something else that's important.
On what? Oh,
So it's that such that each input is doing something. Okay, here's the special requirement. How many outputs can each input have? That's one-to-one is a type of function, but there's something else with it. But each input can have how many outputs? Only one. So a function is a relation such that each input maps to one and only one.
this kid, you know that's what I was trying to say, right?
I don't. That's why we need to be clear with our language. One-to-one is something that matters when we talk about inverse functions at the end of this year, and it's slightly different than just a function.
Yeah.
A one-to-one means that each input maps to one output, and each output only had one input. So it goes backwards and forward, but that's not required for a function.
That's what I was trying to say.
The what? Oh, that's a good point. A vertical line test. I was planning on letting y'all just work on this in your small groups, but, so, Kalia brings up the vertical line test, right? If I draw a vertical line here, how many times does that vertical line hit a point? Or hit the function?
On which one?
It only touches once, right? Okay? So what do we remember about this line? It is or is not a function? That's a function. Okay? What about here? If I draw a vertical line, how many times does it hit the function? Once. Or the relation, I should say. So is this relation a function? Function. But when I look over here, how many times does that vertical line hit the relation? It's one time here and one time here. So is that a function? No, that is not a function.
Not at all.
So the vertical line test, VLT, vertical line test, if the vertical line hits more than one point, it is not a function. However, what I want to point out and I want to emphasize is this. Why the vertical line test works. DeJuan. This vertical line, a vertical line is associated with an input. How many outputs does that one input have? Only one output. How many outputs does this input have? This one. So when that vertical line only hits once, that means that one input has one output.
Yes.
And that's it. Same thing here. But over here, this input has how many outputs?
2.
So that is why it is not a function. And guys, this is important because when you get to a table or you get to an equation, can you do a vertical line test right now?
No.
But you still need to be able to know if it's a function or not.
Yes, sir.
So you always want to go back to the definition of a relation, of is the function or is a relation such that each input maps to one and only one output. And so this is what really defines a function or not. Now John, don't forget, is a function a relation?
Yes.
Every function is a relation because what is a relation? It's mapping of inputs to outputs. Hey guys, I'm going to start class, listen clearly on this. I am going to start class on Tuesday, assuming that you have done these check your understandings to make sure that you know if these are functions or not, so that you can ask questions. How can you check yourself? It's right on the back side. So, listen, hey guys, pause. On your assessments, are you going to be able to just say, function, function, not a function? No. You're going to have to say why. So, practice identifying if it's a function or not, explain why, and then check yourself afterwards. That way you know what you need to ask questions about on Tuesday. Yes, ma'am.
Hey, Frank, give me 13.
Turn it over. Turn it over. Turn it over.
Oh, God.
How about
Alright, they're going to pay for those. I gave you that, bro.
But I'm asking you to practice here.
But you feel like 3 at the moment. You can get like 2.
Yes, there you go.
You can get like 2. I'm making the range of it.
I'm always
What is -2 mapped to? -2 mapped to anything else? -1 only goes to 4. 0 only goes to 2. 1 is delayed for that. Well, inputs go into outputs. Your outputs can repeat, the inputs cannot. So each input maps to one and only one output. And so you want to think about that with both your equations and